Here's an example where you're asked to solve another trigonometric equation. What's different about this one is that the equation involves sine of theta, so just one theta, and then sine of two theta as well. When you've got two different angles inside of those trigonometric functions, they might as well be, sine and secant. They might as well be completely different trigonometric functions. We can't do anything like factor out a sine of theta in a situation like this when the angles are different. And another thing about trig functions, you can't just take something like this 2 and just push it out front. They don't work that way. In fact, there's a formula for sine of 2 theta. So that's the double angle formula for sine, which tells us that sine of 2 theta is equal to 2 times sine of theta. So there, so far it looks like we just pulled out the 2, but then it's also times cosine of theta. And that identity is discussed in an earlier section that you guys have covered. But this identity will help us solve this equation. So sine of 2 theta here, I could write as 2 sine of theta cosine theta, and then leave the rest of this equation the way it was. So sine of theta minus that, we're replacing the sine of 2 theta, equals 0. And now we can factor out sine of theta. We've got this common factor of sine of theta. We can factor that out. And then what's left will be, okay, well, so we had just sine of theta here, so I just put a 1 as a placeholder for that first sine of theta. And then minus, so sine theta was factored out. I'm left with 2 times cosine theta equals 0. So now that we have it factored, we can set each factor equal to 0. So either sine of theta equals 0 or 1 minus 2 times cosine of theta equals 0. And then solve those equations individually. So sine of theta equals 0. If you look at a unit circle, I'll just draw a little sketch over here. Sine is the y-coordinate when we look at points on the unit circle. So the y-coordinate is 0, meaning sine is 0 here and here. So that's at 0 radians and pi radians. So we get those two solutions from this equation. Now if we solve this one, I would probably add 2 cosine theta to both sides. So I have 1 equals 2 cosine theta. And then divide both sides by 2. So I have just cosine theta equals 1/2. And again, at that point, once you have the trig function by itself, then you can pull out your unit circle and look for when is the value of cosine theta equal to 1/2. Cosine, remember, is equal to the x-coordinate. And so the x-coordinate, you'll see 1/2. You'll see these coordinates at pi over 3 radians. And x equals positive 1/2. That'll happen again down here in quadrant 4. Where you'll see coordinates 1/2 and then negative square root of 3 over 2. I'm having trouble writing the negative square root of 3 over 2, but we don't need that anyway, so I'm going to leave that out. This is at, what will this be? 4 pi, 5 pi over 3 radians. And so we get those two solutions to this equation over here. So either theta equals pi over 3 or theta equals 5 pi over 3. And so these 4 values are your solution set to this equation: 0, pi, pi over 3, and 5 pi over 3.